Okay, welcome everyone. Welcome to this webinar all around API security by design, where we'll be focusing on patterns and principles for designing secure APIs. So this is a joint webinar by SmartBear and by the broader API community. So just a little bit of housekeeping before we get going. This session is being recorded and all registrants will receive a copy of the recording as well as the slideware for your on-demand viewing pleasure. If you do have any questions throughout the webinar, we do encourage you to use the Q&A facility in your Zoom window. Feel free to use the chat as well, and we'll do our best to keep an eye on both and have some time for dedicated Q&A towards the end. There will be some polls popping up throughout the session just to gauge your feedback on a couple of points, a couple of questions. So with that, let me just start by introducing myself. My name is Kilcommins. I'm an API Technical Evangelist at SmartBear, and I'm delighted to be joined by José Haro Peralta. José, would you like to say hello to everyone?
Sure. So my name is José. I am a consultant, author, and instructor based in London. I work on all areas related to microservices and APIs. I'm the author of this book over here, Microservice APIs, that I published recently with Manning. We're going to raffle a couple of copies of the book for this webinar. And I'm the founder of microaps.io. I'm very excited to be here. Thank you, Frank, for the opportunity to do this webinar with you.
Oh, excellent. Delighted you're here, José. And there's a QR code on the screen if anyone wants to grab a copy of José's book, and we'll be showing that again later on in the webinar. So the agenda for today, we're going to talk about what is API security and maybe prefix that with a little bit around why API security is so relevant right now. We'll look at the broader context of API security. Of course, it's a very big topic. So we'll jump into the recently published OAuth Top 10 Risks for APIs, which have been refreshed in 2023. We'll spend some time going through authentication and authorization patterns and ways of approaching that. Looking then at the broader architecture and infrastructure surrounding your APIs. And then we'll be diving a little bit deeper into the design and baking security into design. We'll zoom out a little bit then across the API lifecycle and talk about the different phases in the API lifecycle where you can have a good security posture. And we'll spend kind of let's say the last third of the webinar going through design vulnerability considerations and how to tackle some of those. So I think a poll will be popping up now, and José has kindly given us some free ebooks. So participation in these polls will enter you into a raffle for some of those ebooks, as well as some free signups for a course on APIs using Python, which is also by José. So leaving it up on screen here for a moment, just for the benefit of those watching on demand. Okay, so let's get into the meat. So before we jumping into what API security is, I think it's always good to understand why API security really matters. So, we're all in the crux of delivering more web and digital oriented solutions. APIs are the fabric that makes those communications possible across the different software components. And when we look at some industry findings, what we're seeing is that Verizon in a 2021 research report showed that 39% of all breaches for the web in general were made up of web application breaches. And when we look at this from an API perspective, what we see in our own research at SmartBear is that security around APIs is the number 2 challenge that the industry would like to see solved broadly. And I think it's also good to focus on kind of when we think about the attacks that are happening on APIs, is that increasing or is it leveling off? Well, our friends over at Salt Security, who can specialize in security research for APIs, did a very interesting report which compared API attacks in the first half of 2021, comparing it against the API attacks in the latter half of 2020. And we saw an increase of 348% there, which I think is very, very eye-opening. And it means that we all really, really need to think about the more APIs that we're exposing, the greater the surface area that is out there to potentially bad actors. And we need to be able to mitigate against the risks. So with that, José, would you like to give everyone an intro as to how you would frame API security?
Sure. So API security is that field that deals with everything that has to do with securing our APIs. And securing our APIs is not only preventing users from breaking into our system, it is also ensuring that our APIs are working reliably and correctly and doing everything they're expected to do. If you think about a lot of attacks that can be done against our API, like a DDoS attack, the point is to bring down our servers. So the question here is how can we protect our APIs against all these sorts of attacks against the API? It covers everything that goes from architecture to infrastructure to design, implementation, and automation of the API. We're going to cover a lot of these topics. And what we're going to do is we're going to give you advice on how you can tackle each of these issues from a design point of view. And this is very important because design ideally is something that comes before the implementation. So it means you shift completely to the left your concerns about security, and you put yourself in a much better position to tackle API security in your system.
Great. Thanks very much, Jose. So basically, you talked about kind of the broader context of API security, and it kind of touching many different facets of, let's say, the design, the implementation, and then the actual running instances themselves. So that's what we're going to kind of jump into now, is kind of making everyone aware of some of these broader topics. And I think a really good place to start is looking at what are some of the kind of common threats that are out there that everybody needs to be aware of and everyone needs to try to mitigate. And OWASP have recently published their new kind of reframed 2023 API risks. And of course, OWASP is the Open Worldwide Application Security Project. So they've changed their name recently from Open Web to Open Worldwide because they see these kind of risks being relevant across more than just web technology. So they're kind of branched into it from an IoT perspective, and also from embedded software, and even now into large language models and things like that. This is a list of the top 10 for 2023. And what we're going to do is give you a brief overview of all of these. So Jose, I'll let you kick it off.
Thank you. All right. So the first vulnerability we're going to see here, broken object level authorization, is the first vulnerability listed in the OWASP list. So what is this? So this is the ability of a user to access resources or operations in a server that doesn't belong to them, or they shouldn't be able to access to. They shouldn't be able to access. So like in every API, we're going to have a concept of resource ownership. There are things we can do and things we can't do. And so to illustrate this, if you think, for example, of a blogging application, we can author publications, and as the author of the publication, we can edit them or we can delete them. Ideally, other people can't do that. They can see our posts, but they can't modify them. And so broken object level authorization would happen if a user manages to bypass these access mechanisms and get hold of our publications and modify them or delete them. Like, this might seem something trivial in a blogging application, but if you think of a banking or you think of a medical application, it's very important to make sure that users can't access data or resources that doesn't belong to them. So what do you think, Frank, we can do here to prevent this kind of vulnerability?
I think the first thing to do is make sure that for all relevant endpoints, you think about the access and how you will scope that access accordingly. So ensure that you have the concept of defined scopes for the different objects that are being exposed through those endpoints, and making sure that there's a mechanism there to validate those scopes before you serve back the resources towards the client.
All right, that makes perfect sense.
Okay, so the second one is broken authentication, and this vulnerability will generally occur when there's a weak authentication implementation or even no authentication implementation. So if you think about this from an example perspective, let's assume that we have a sign-in endpoint, and if we allowed the client to repeatedly send requests using various combinations to try and basically brute force the endpoint until they can get access to it. So, Jose, what would you think would be a good security by design approach to mitigate this risk?
I think the first thing I recommend to everyone, all my clients and everybody who's working with APIs, always, when it comes to authentication, use an identity provider. Don't try to do it yourself. If you don't have a very strong reason to do it, it's going to be more expensive and more complicated, and you're likely to make mistakes. So there are a lot of services out there that are specialized on this. They have battle-tested systems, and they're going to be cheaper to use and much more easier to integrate with your system. So that's the first thing I would recommend. But also make sure you have proper configuration in your system in place, like good rate limiting policies to make sure these kind of brute force attacks can't happen. Make sure you're using strong algorithms to sign your keys and your tokens, and you're rotating those keys often. Those are some of the things I would recommend here.
Yeah, that makes sense. And we'll jump a little bit more into some of those signing algorithms a little later today as well.
All right, so next one is broken object property level authorization. So we mentioned before this idea of broken object level authorization. So that's the ability to access resources that don't belong to you. In this case, the idea is having access to properties in those objects that you shouldn't be able to access, to modify, or to read. So it happens in two ways. This vulnerability in 2023 brings together two vulnerabilities of the 2019 edition, which are mass assignment and excessive data exposure. So excessive data exposure is when you are leaking more information than you should to the users of your application. If you're thinking of a medical application, for example, you may be leaking patient records or details about the patients that certain users shouldn't be able to see. In terms of mass assignment, is the ability of a user to override what we call server-side or read-only properties. So if you think, for example, here of an e-commerce application, you place an order, the order hasn't been paid yet, the status of the order is unpaid. If a user sees this property through the API and they try to override it and they manage to do it, then that's when we have a mass assignment broken object property level authorization breach in our API. So what do you think, Frank, we can do here to prevent this problem?
I think, well, I'd say first things first, kind of starting from an outside-in approach with regards to how you design the API is a good way for making sure that you will only expose data that's needed to solve the intended problem. So you're not just exposing all data that you have. So if indeed you're then exposing operations that are more for reading, make sure you're kind of limiting that down, that you're not exposing maybe kind of server-side properties that might be used to manipulate other endpoints. You can use maybe patterns like CQRS as well to kind of separate the reading and the more command-based operations against your API and have different schemas being used. So I think they're all kind of approaches that I would see as being common and to try to mitigate this type of issue.
That makes perfect sense.
Okay, the next one that we have is unrestricted resource consumption. So this is, it went through a bit of an evolution in 2023. For anyone familiar with 2019, this would have been kind of referred to as lack of resources and rate limiting. And what this is about is that it's a vulnerability that would allow malicious users to launch brute force attacks or denial of service attacks against our API. So again, if we have a publicly accessible endpoint that itself is kind of, let's say, open to be consumed, so something again very common like your sign-in endpoint, then someone could set up some automation to try to brute force and keep sending combinations there until they eventually break in. So, Jose, how can people address this type of situation?
I think something important here is to leverage your infrastructure, first of all. So if you're using something like Google Cloud, Azure, or AWS, there are always elements in your service providers that will help you have some built-in rate limiting by default in your system. So if you use things like API gateways or CDN distributions, if you use, for example, Cloudflare to serve your services through the internet, all of these systems will have some sort of mechanism to monitor user activity and rate limiting rate limit what they can do, or even block those users temporarily from using the system. So use those things by default. And then have across the stack put as much any measure you can to rate limit the usability of your endpoints and things like that. That's the kind of strategy I would recommend here.
Yeah, that makes good sense.
All right, so broken function level authorization. So again, related to the ability of users accessing data that doesn't belong to them, what happens here is in most APIs, we have a concept of user groups or user functions. So depending on which group we belong to, we will be able to perform certain operations or we will be able to access certain resources. Perhaps the most common differentiation here is between admin users and normal users. So admin users typically will be able to perform nearly any kind of operation on the system, and normal users will be limited to what they can do as a user, as a normal user. And so this vulnerability happens when a user can bypass those kind of role-based access controls and assume or perform operations that don't belong in the class of user they belong to. So I think a common way this happens is often we have specific endpoints for different user groups. So for admins, often we have a specific admin endpoint. It can be a subdomain, it can be a path, a URL. And because it's a different endpoint, sometimes we assume this endpoint is going to be accessible only within a certain VPN or in certain restricted conditions or restricted environment. And so we assume that the requests coming here are going to be legit. So we don't implement full role-based access controls in those endpoints. This is a mistake because for any reason, those endpoints can get exposed and people can figure out those endpoints exist and get access to them. So the example here, a user may figure out they don't have access to operations that belong to other users, and they try through an admin endpoint and they manage to get access to those resources. So what do you think, Frank, we can do here to prevent this issue?
Yeah, I think the first thing is try not to make poor assumptions as to the origin of traffic. So don't necessarily trust the clients or that all traffic will come from an east-west perspective, that it all will be within the firewall. So kind of treat your admin endpoints as if they were publicly exposed. And in many cases, they will be publicly exposed. And really have kind of the concept of function-based scopes. Apply those strictly to those required endpoints and make sure that they're always validated appropriately.
Well, I think that's very important, right? Zero trust approach, and always consider all the endpoints as if they were public.
Yeah, exactly. So the next one we have is unrestricted access to sensitive business flows. So this is an interesting new addition to the list this year, and it really occurs when users or bad actors can leverage information about underlying business flows or business information to basically misuse or abuse the API. So if I was to give an example of this, let's assume that we have a products API and that's being exposed to an e-commerce application, and we're about to launch a new product. Some bad actor learns that we're going to be launching a new product on a specific day at a specific time, and they set up a coordinated, automated approach to basically go and buy all of the new products. And then we have no products anymore, and then they will increase the price and they will sell those products through a third-party offering. So Jose, I think this is a very interesting one. So how would you recommend folks to mitigate this issue?
So I think, first of all, like you say, it's a very interesting addition to this year, and it's really difficult to deal with this. I think one of the things I would recommend, first of all, is have proper monitoring and of the user activity in place, and actively monitor that user activity and respond, like have it reactive. Like as soon as you can identify non-human patterns of interaction with your site, because a lot of these attacks will be automated, then have those patterns flagged, rate limit those users, and maybe block them immediately. Perhaps something we can leverage here is the workflow specification that you, Frank, are leading efforts on this development, because you can use it to define user flows, right? And maybe you can use these to identify unusual flows of users through the API. How do you think we could leverage that in this case?
Yeah, I think it's an avenue of investigation, at least, so the workflow specification is indeed about defining kind of those business-orientated flows through a series of chained API calls and to make a meaningful understanding to the consumer. But it can also be used to describe normal execution or normal flows for getting access to a specific end result. So if you're then actively monitoring how potentially these automated requests are retrieving the products, for example, we may be able to determine that it's not a human user at the end using the client making these calls. So for example, we would expect users to first browse the products or maybe see products that are organized by launch date, and then go into the details of those products. But if we could see a whole series of requests going straight into a specific product by ID, which would be a fairly opaque identifier, and then we would know that potentially they're using some insider information here to make those calls. So that could indeed be a useful use case for the workflow specification. Jose, thanks for bringing that one up.
Thank you to you for leading that effort. Right. So next one is server-side request forgery. So this is the ability of a user to trigger requests from within our server for various purposes. A common purpose here is to run a port scanning within our server and figure out which services we are running together with the API. So of course we are running an API server within the server, but maybe we have also a database, maybe we have some configuration system that are running within the server, they are listening on a port, and a user may figure out those services are running inside and maybe they can get access to them. So the way they will do this is, there are some situations in which we have to ask our users for input in the form of URLs so that we can pull content from that URL. Imagine, for example, we have a process to set up the profile of our users, and we ask them to provide a URL for their profile picture, so a gravatar or something like that. And then a malicious user may figure out they can leverage this feature to include requests to the local host with different ports to see, analyze the response time and the type of response they get back to see what services are running inside of our box. And so they may try launching a request, like here in this example, to the default Postgres server. And if they get, if the Postgres is running, you launch an HTTP request, we're gonna get a reply that is an empty reply from the server. If that response leaks through the API and the user sees that, they will figure out we have a Postgres service running inside our server. Then we try to get access to that. So the point here is that they can leverage this information to build a profile of our services and plan a launch attack against our API. So what do you think, Frank, we can do here?
Well, I think from a design perspective, we can have the concept, at least within the implementation of the design, that we would have an allow list or a green list of domains that we would accept in that particular property, and or apply some regex patterns to ensure that it's a correctly formed URL and some other type of injection. And I would say, secondly, we should also, if we know that it's going to be a URL, then if we have the ability to run it through some form of security scanner before we persist it or execute on top of it, that would be also very, very good.
Right, this is a very difficult problem, right? But as much as we can do to prevent it.
Yes, indeed. So the next one is security misconfiguration. So indeed, errors in configuration of our APIs, the servers that are hosting those APIs, the code itself, or other surrounding infrastructure can cause vulnerabilities. So most, coding frameworks that we work with allow us to specify a debug flag or debug mode, and that helps us, solve problems, troubleshoot problems, and really understand how the API is functioning on the targeted environment. But it's often a very common mistake or error that that type of flag might find its way up the chain towards a production environment. And that would enable malicious actors to use that more verbose data to maybe coordinate and exploit some vulnerabilities. So Jose, what would be some good recommendations for this type of risk?
Right. From a design point of view, we want to make sure we are applying restrictive and secure configuration across the stack by default. So, like you said, some frameworks, or perhaps all frameworks, allow us to run the web server in debug mode or production mode. Then let's make it by default production, so that we don't run into these issues by accident. And then if we want to run in debug mode in certain environments, then we can switch on that flag actively. Sometimes we also have the ability to run our services with authorization on or off. So then by default, let's switch on those parameters so that the service is running securely by default. And then in targeted environments with very controlled conditions, we can then switch off some of these flags and be able to see what's going on behind the scenes. But by default, let's make all these configurations secure.
Yeah, and I think having kind of the concept of kind of well-known configurations for target environments and having those validated as part of CI/CD flow is good practice.
100%. All right, so next one is improper inventory management. This is basically a rename of a previous vulnerability in 2019. It was something like improper asset management. So what is the concept of an asset when it comes to APIs? An asset is anything that allows us to expose operations through the API. So an API version, the whole version of the API is an asset here. An endpoint can be an asset. An HTTP method can be an asset. And so the question here is, as the API evolves and it changes through the lifecycle of development, we're going to get new versions of the API. We're going to deprecate certain endpoints or HTTP methods. And so the important thing here is that when we aim to retire those previous versions or endpoints, the important thing is that we actually do it. Because a lot of the time we release a new version of the API with security improvements and patches, we forget to retire the previous one. And so if a malicious user discovers that those versions or those endpoints are still live, they can leverage, they can exploit this vulnerability to try and break access into our API. So what do you think, Frank, we can do from a design point of view to prevent this?
I think there's a few different tactics. So I think, designing with extensibility in mind is a very important one. So that allows you to evolve and enhance the API without having to, let's say, introduce new major versions, deprecate older ones, or deprecate endpoints. So as much as possible, always think about extensibility here. It means you can have less variations of, let's say, live APIs out in the wild. But you then also need to be able to manage your API portfolio. So having the concept of an API portfolio, an API catalog, where you're recording the different metadata about the APIs so that you can make good informed decisions, and that keeps your architectural metadata also up to date. We don't want these APIs to kind of fall into that zombie state. So there should also be tests there. So if you are deprecating something, make sure that you've tests as part of your CI/CD flow to fully validate that they are no longer accessible and in production.
Perhaps an idea here, a lot of these API gateway products allow you to manage this versioning and releases of the API. Perhaps an idea here is to also ensure that when we are deprecating an endpoint, is to make sure the new version of the API certainly doesn't have that endpoint. It's something they certainly could do.
Yeah, absolutely. Makes sense. Good suggestion. Okay, so now we have unsafe consumption of APIs. So we are in, hard to believe, it's the 2nd of August, 2023. So I think all applications that we're building are consuming third-party APIs. So UCA happens really when we fail to validate the output from those APIs, and that can leak malicious content into our own systems. So, for example, let's assume, it's an example you touched on already, Jose, that we have a process for setting up a user profile. We may pull information from a third-party app or API to help us hydrate that profile. Potentially, a malicious user might have set up some data in that third-party app, so they might have put in an injection type of query into a particular value. Maybe that third-party app is, correctly escaping that and not executing anything. But if we pull that information, perhaps that would be persisted and executed on our side, which could cause harm for our backend storage. So Jose, what can folks do to help overcome this type of situation?
Right. So I think the first thing we have to do is embrace zero trust approach. So normally we understand that we can't trust input from our users as it is. We have to do some validation, some filtering, sanitization of the input, and so on and so forth. I think we have to understand, like you said, we're 2023, a lot of integrations out there. We have to bring this approach to our integrations with other systems, not because those systems are necessarily malicious, but because users may find a way to introduce malicious content into those sites. Like you said, those websites maybe are doing things correctly, escaping values or parameterizing them and so on and so forth. So maybe they're not vulnerable to that, but they may be exposing our system indirectly to those vulnerabilities. So we want to make sure we are adopting this zero trust approach. We validate that data incoming from those integrations. Those integrations have APIs, they have documentation. We know the schemas, we validate according to those schemas. And if the input or the output, the data they are sending to us is invalid, we reject it. We also want to make sure we are sanitizing, filtering, and inspecting the content, and that before we run that content through our database, make sure we are parameterizing all of our queries so that that data gets inserted safely in our system. So definitely we want to do those things.
Yeah, makes sense. There was one that we didn't cover, which is not officially part of the 2023 list. It's on the 2019 one, and we still think it's very relevant, and that is injection. And that will be covered in the slides that we'll share, but we just didn't have time to cover it as part of the live discussion. So the next one we're going to move on to is authentication and authorization, and there can often be a little bit of a confusion as to what these things are. So Jose, I'll let you take this away.
All right. So authorization and authentication are actually the most visible parts of the API's security process. They are not the only ones. Like we've seen, there is the whole thing of OWASP, and we're going to see a lot more about design vulnerabilities, but these are the most visible parts. And so authentication really is the process of verifying a user identity to verify that they are who they claim to be. And that's the end of it. And then authorization is the process of validating that a user has access to whatever resource or operation they are requesting in our services. And so that's the distinction. And now we are going to see in more detail what they're all about.
Yeah, so we'll start with open authorization, so more commonly known as OAuth. And OAuth is a standard for access delegation, so it's all about delegated authorization. Typically, there's 4 actors involved in any type of OAuth dance. So there's the resource owner, so that's a user or a client that owns the specific data resource that's being requested or manipulated. There's the resource server, so that's the server that's hosting and serving that information back towards the resource owner. There's the client, which is the software that's facilitating the transfer of that information between those 2 former actors. And then there's the authorization server, and that's the server that issues the client the appropriate access that it needs to access the resource server on behalf of the resource owner. The flows that are common and recommended from an OAuth perspective are the authorization code flow, an extension on top of that, which is known as PKCE. And we have client credentials, and we have the refresh token flow. On purpose here, I've included implicit flow and resource owner password credentials, and I've struck them out because really they are not fit for purpose anymore, so folks should not be using them.
All right, so let's begin with the first.
Take us through authorization code flow.
Right, so let's begin with the authorization code flow. The idea here, and actually the Open Authorization Specification 2.1 recommends we use this flow in combination with PKCE, but a lot of implementations out there still implement the authorization code flow. And so the basic idea here is we have a backend, we have a website with content generated in the backend. So if you think like something like Ruby on Rails for Ruby, or you think of Django for Python, typically in these applications we generate the content in the backend. So we don't have we can use them with an SPA if we wanted to, but they have the capability of generating content directly in the backend. And so in that situation, we have full control over how we generate the content, and we have full control of the interaction with the user. So this allows us to have an integration directly between our backend service and the authorization server to control the authorization process. So what will happen here is a user comes to our service, they don't have an authorization token. So what we do in our backend is we talk to the authorization server and we tell them we want to get a sign-in URL for this user. And so we redirect the user to the authorization server. It's going to have a callback URL that is going to come back to our server, of course. So if the user signs in successfully in that URL, they will be redirected to our server, and this URL will have a code in the URL, which we can grab in the backend to exchange for an authorization token and obtain this authorization token that we can pass on to the user. What's going to happen also in the middle, because this request can be intercepted, most implementations out there are going to give us also some state parameters, so that when we initiate the request, we're going to have some state parameters that we keep in memory, and then we use them to make the final exchange between the codes and the access token at the end. So that's the gist of this flow.
Great. And then the PKCE Flow is kind of on top of that, and it stands for Proof Key for Code Exchange. And it would have traditionally started from a single page application perspective, so an app that runs within the client browser. So inherently, it was impossible to keep something like a client secret, which is used in the OAuth flow or the authorization code flow secret. So we had to do something else in order to make this exchange more secure. So what it does is you will have the client application that will generate a code verifier and a code challenge. We'll pass the code verifier along with the initial request to the authorization server. When the code comes back, then the client will pass back that auth code towards the authorization server, along with the code verifier that will be then validated, and assuming everything goes well, then the access token will be returned. So again, it's like a more advanced version of the state management technique that Jose would have talked about in the previous flow, and it prevents any type of man-in-the-middle situation where someone will grab that auth code and use that to redeem and obtain an access token.
All right, so now client credentials flow. So if you think about the previous flows, what we've seen before, the authorization code flow or the PKCE flow. So if you imagine we have to do all this dance with a microservice, so imagine, because APIs are also for microservices integrations, right? So imagine in a machine-to-machine communication context, if we had to do the whole dance, it would be very complicated and tedious, right? Imagine a microservice going through the whole PKCE flow. So although that would be doable, for machine-to-machine communication, there is a simpler flow that is meant to be used exclusively in this context, and it allows us to exchange a client ID and a password directly for a token. And it's supposed to be used exclusively in this machine-to-machine communication process to enable integrations in distributed platforms for microservices and things like that.
Indeed. Okay, and the last flow that we'll be covering from an OAuth perspective is the refresh token flow. So specifically, when you think about scenarios where there is a resource owner who is a human involved in this negotiation, they will be challenged to enter their credentials in order to be able to give the authorization server confidence that the client is indeed interacting with the resource owner. But in many situations, we don't want to have to burden the human to re-enter or be re-challenged interactively for their credentials. So if I have given a client permission to access a resource on my behalf, then I will want them to kind of keep that permission active until I determine that I no longer want this client to have access to my resources. And the way that this works is the authorization server, along with issuing an access token back to the client, will also supply a refresh token. Now, all access tokens have an expiry, so they will expire somewhere between an hour, a day, a week. It's configurable, and there's nuances between the different providers, but they will expire, and that's the important thing. So the client's application has the ability to use the refresh token to obtain a new access token and refresh token pair, so that interaction can continue to happen without me as a human needing to re-enter my credentials. But I will always have the ability to revoke access for a client. And again, this is another good reason why you shouldn't implement OAuth flows yourself, and you should use off-the-shelf reputable authorization provider implementations, is because you also have to deal with these complex refresh token and token revocation flows as well. So that was a lot about authorization, Jose. So moving on to authentication on top of that.
Right. So that was authorization. There is the other topic of authentication. Like we said, it is the process of validating a user identity. And we can, there are various ways we can go about this, but one of the most common strategies to implement authentication in APIs is using OpenID Connect. So again, this allows us to leverage identity providers and services like that to make sure we don't have to implement those things in our system. OpenID Connect is the most commonly used approach to this. It is a strategy for verifying user identities that builds on top of open authorization. So like you see in this image, it uses a concept similar to the flow in OAuth. So you can think of identity here as a resource that we are gonna delegate access to by using this mechanism. And the important thing here is when we use these process to manage user identities, what we're going to do is we're going to redirect the user to the identity management server to prove that they are who they claim to be, and they get access simultaneously to our APIs. What we're going to get out of this process, if the login is successful, is we're going to get an ID token and an access token, like you see that in the image. An ID token contains identifying information about the user. There are a lot of claims we can use here, including the date of birth, email, first name, surname, and so on and so forth. We decide which claims we want to include in collaboration with the identity server. And that token, because it contains identifying information, stays in the client. Once we get the token, it doesn't fly back and forth. It's not an authorization token. The authorization token is the access token that doesn't contain, ideally, it doesn't contain identifying information about the user, and therefore it's very suitable for these back and forth communication and exchanges between our server and the client.
Okay, well, that makes sense. And so we've spent the last kind of few slides showing these different flows, and kind of the common theme across all of the flows is that there's tokens being exchanged, and those tokens basically are the keys to get access to the resources. And so what kind of mechanisms are out there, Jose, for kind of minting these tokens? You know, what standards are there? What type of information is contained within these tokens?
Right. So like I said before, first of all, there are different kinds of tokens. There are actually different ways of classifying the tokens. We have one way of classifying them is between ID tokens that only make sense. So it's a type of token that exists within the OpenID Connect integration, and there are access tokens, which are the tokens that we use to validate access to our APIs. Now, there are different ways of or there are different types of technologies we can use to implement access tokens. The most common one of them, and the most widely implemented, is JSON Web Tokens, or JWT. And so there's a standard specification for this type of token. As you see here, they have typically this kind of a structure in 3 parts. There is a header that tells us what kind of token we're dealing with, in this case, a JWT or a JWT. It also tells us which algorithm was used to sign the token. In this case, it's talking about RS-256. What I have to say is, even when we use an identity provider, we have control over which algorithm was used to sign the token. So we can have an expectation there. A common vulnerability when it comes to JSON Web Tokens is a user can set the value of the algorithm property to none or null, and that means there is no signature to validate, and so they can bypass the authorization mechanism in our API. It's been a very common vulnerability in the past. What I would recommend here is we know which algorithms are used, so we have that expectation in the validation process. Then we have the payloads with the claims. The claims are the properties that contain information about the access rights of the user. So they have properties like the issuer, what's the authorization server that issued the token, what's the audience, the intended audience. Very important, that should be our API. If it is not our API, we'll reject the token. It has the expiry date, when the token was issued, the subject, which is a sort of ideally a kind of opaque identification for the user, some sort of opaque ID. And we have the signature that tells us that the token is legit. Now, in terms of signing algorithms, Frank, what do you think are best practices when it comes to that?
Well, I suppose I speak from personal experience. I think that the most common one that I've used is RS-256, and it's more or less kind of secure by default. It seems to be one of the most common out there. Of course, that's a public-private key type of implementation. So even if the public key gets leaked, it's not the end of the world, because that's only for verifying the signature. But no matter what you use, you need to kind of cycle those keys frequently. HMAC is also common, maybe not quite as performant, maybe a little bit heavier, more of a just a kind of a secret approach. It'll have a long type of password there included, but they're kind of the most common. But as you said, no matter what it is, when we're verifying these things, we should ensure that the algorithm is as we expect. We should also validate the signature to ensure that it's correct, and we should inspect and verify the claims therein. So making sure that it's still valid, it was issued by who we expected it to be issued for. The subject also makes sense, so it's opaque to the client, but it's not opaque to the provider. And we talked about scopes in a lot of the previous slides with regards to how to validate certain things. And this is where the scopes are persisted. So they're contained within the claims that are passed in these tokens.
100%. I think this idea of rotating the key is also very important. We should use that feature all the time.
Great. So we covered quite a lot there, and thinking about how we can apply all of these things from a security by design for API perspective. Of course, there's surrounding elements to the APIs. So there's the architecture and the infrastructure. So implement your APIs in a private network as much as possible. Make sure that you have an application, a gateway or a web application firewall. Use API gateways for rate limiting, for throttling, and don't make poor assumptions around that kind of east-west traffic. So make sure that your databases are sufficiently separated from your actual API implementation, and optimally they will be in a private network. We talked a lot about authentication and authorization. So securing your tokens, validating those signatures, not reinventing the wheel when it comes to OAuth. Rotate keys often. And one of the most important things that we think about is from a design perspective. So leveraging specifications and being aware of design vulnerability pitfalls. And that's what we're going to start moving into for the remainder of today. But thinking about the API lifecycle in general, just very, very briefly, of course, this brings us through the process of understanding the problem that we're trying to solve, ideating, picking the right style of API to solve that problem, then designing it, developing it, testing it, deploying it, and then managing it into production. So it's very, very easy for us to bake security into all of these different phases. And we do have slides that are going to be part of the pack that will be shared out that will go into more details on how you can apply security across all of these phases. So that will be included in the slideware that you will receive. I think another poll is going to pop up now just to make sure everyone is still with us and ready for the last section. Great, so that's popped up. So we'll leave that there behind the scenes. And what we're going to move on to now is start thinking about design and how we can incorporate security into our design process. And because we're all in the process of exposing more APIs, and of course that increases the surface area that malicious actors can take advantage of, and a flawed design can really have a big impact on the security posture of your APIs. And myself and Jose we're discussing kind of common pitfalls in preparation for this, and this is the full list of items that we've come up with. And again, we'll cover all of these in the slideware, but for the sake of time today, we're going to just cover 4, and then we'll move into some Q&A. So the first one is leaking objects. And what does this mean from a design perspective? So it really means that we're exposing more objects than we should in our responses, and or more objects than an end user of the client consuming application should see. So we're either doing that process, maybe it's more of an inside-out approach. We have database schema, we're kind of blindly converting that into APIs, and we're serving that, assuming that it's going to solve the problem, and we're putting the burden on the client to actually filter out the objects appropriately. It can also be then, it can manifest itself into the properties or the representations of those objects. So payloads can have maybe nested structure where we're giving access to even more information. That can be PII data, and that can have kind of serious regulatory fines for us as well. So it's something that we need to be aware of. So some examples of this, let's assume we have a products API, and that products API also exposes loyalty discounts to certain customer tiers, for example. And if we weren't very careful about that design, we may blindly expose all of those tiers to a consuming application. Perhaps even the consuming application is a tolerant one, and it does filter out what we ask it to filter out. But anyone that's looking at that network traffic can indeed see all of the discounts, and maybe they can get access to an ID for one of those discount codes, and then can use that in subsequent purchasing calls. And we don't have any additional validation on that because we're assuming the workflow is as we expect. With regards to leaking full object representation, so if you have a ride-sharing app, maybe we're exposing certain information about the driver and about the car, but we're including a lot of additional information there that's not relevant for the app. So maybe we're or exposing the driver's license number, for example, maybe even their date of birth. So these are all things that we need to be careful of. Jose, how would you think we can overcome this type of design vulnerability?
Right, so I think we have to tackle both of them separately. The first one, this idea of sending more objects than we should through the API. I think what we have to understand here is this concept of user groups or functions that we mentioned before. We have to bring it across the whole cycle of our request and response processing. So it's important not only to validate user access to the API, it is important also to make sure that we are delivering the right type of data to our users. So bring this notion of user groups and user function to our data delivery strategy. But then when it comes to object representations, like you said, this ability to represent nested objects within our responses, I guess what we have to do here is understand that the representation of an object or a resource has to change depending on the context. So if we are, like you said, right, this ride-sharing application, we are the driver accessing data from the server, then it makes sense to have full access details of our car and our user profile. But if we are a user who's going to take the ride, then we don't need to know what's the ID in the system of the vehicle or other personal information about the driver in that payload. So we have to make sure we are designing the right payloads for every context. And we can use perhaps, because sometimes what happens here is we want to use the concept of code reuse and schema reuse. So we have a single entity to represent the car, and we use that entity across the different schemas to combine them. Perhaps what we can do here is have a base representation of the car in a base schema, and then we can use composition to represent more complex details about the car in different responses. And so that way we can differentiate the responses of one user from the other.
Makes sense.
Right. Okay, next one, integer identifiers. I think this is a classic vulnerability in APIs. I think we've been aware of this since we were using APIs. So IDs, obviously we need IDs to identify resources. One of the most common type of IDs is integer, right? They are natively supported in most databases. They are very efficient to use in relational database systems. And so often we just use integer IDs, and that's fine. I think the question here is we have to make sure we don't expose those IDs directly through the API, because the moment our user sees they place an order and it gets a number, and then they place another one and it gets another sequential number, they figure out there's a pattern here of integer IDs, and they can play around with different numbers to try and get access to different resources. So it's, even if we use integer IDs in our database management system, we have to decouple that from the representation of that data through the API. So what do you think, Frank? What can we do here to prevent this kind of problem?
Yeah, I think the first is non-sequential identifiers for your API resources. So use something like UUID or ULIDs, or there's other kind of higher performant options out there as well. If possible, yeah, like you may have one structure in your database, but you can abstract that from your API representation. And again, that may even be to your advantage from, let's say, a code management perspective into the future. Because you're kind of decoupling those different layers as well.
A common strategy sometimes is to hash. If you're using integer IDs, you hash them, right? And you get a different representation in the URL.
Correct, yeah. Okay, moving on. So we have a few moments left, and we do want to leave a few minutes for Q&A and wrap up. So what we'll talk about is just exposing server-side properties and user input. So of course, APIs in general have a lot of server-side properties that are happening. So that can be the IDs, it can be timestamps of when these records are created or modified. We can have also more functional metadata as well, maybe kind of customer tiers, user roles or privileges, maybe loyalty points. So for example, if we had an orders API, and for the sake of schema reusability, we had the same API for getting the details of an order as well as creating a new order. And that included the status of the order. Then if we had that mass assignment vulnerability, then potentially we would allow someone to update the status of an order, and we wouldn't be verifying that that specific property has changed because we weren't expecting it to change in that resource. So Jose, any recommendations here?
Sure. So I think just like we said before, we use different schemas for different purposes. So we have a schema to read data from the server, and we have a different schema to obtain input from the user to represent the resource when it comes to the server. So server-side properties like obviously ID or the created timestamp, or like you said, the status of an order and things like that, we don't expose them through the schemas of the user input. I think that's the basic recommendation here.
Yeah, and mapping objects appropriately as well, using kind of data transfer objects can help, and making sure that we're not just blindly applying these things to the storage there.
100%, yeah. All right, so next one, flexible schemas with unknown properties. This is very related to what we saw before, but it has a twist. So the problem before is that basically we use the same schemas to read data from the server and to obtain data from the user. And so we expose those server-side properties directly to the user. What happens here is we may have schemas without those properties, but they are not strict schemas. So it means they allow the user to set additional properties on the payload, and that won't be a problem because the schemas aren't strict. And so we may have an endpoint that allows the user to update an order, and the schema for that endpoint doesn't expose or doesn't declare a status for the order in that payload. But the user may figure out when they retrieve data from the API, they figure out there's a status property there, so that maybe they want to see what happens if they set the property status in the payload to paid when they send data to the API. And so if we have flexible schemas that don't reject payloads when they have unknown properties, then they may be able to overwrite that data. So we may fall into another mass assignment vulnerability in the API. What do you think, Frank, we can do to prevent this?
Well, there's different techniques. It can, of course, depend upon the style of API that you're using and the additional kind of specifications that support you design artifacts according to that style. If you're using something like OpenAPI with JSON schema support, you have the concept of additional properties, and you can set that to false, which basically means this is the schema and nothing else can be provided by the client towards the server that isn't part of this defined schema. And there's something new in OpenAPI 3.1, so JSON schema 2020-12 around unevaluated properties. And again, that gives better mechanisms to kind of validate the integrity of the messages that are being passed. A little bit like what we talked about in the previous vulnerabilities, we can also do proper assignment of these properties as we're moving them down through our layers, and use data transfer objects to explicitly transfer that data. So all of those techniques will definitely help.
Awesome.
Great. Well, thanks everyone. I think we got through a chunk of information. So maybe just to summarize it, and there's more information than what we even covered, which will be shared in the slideware. So we will be going through all of those common vulnerabilities that I listed at the start of the last section. So we took you through API security, what it is, why it's important, the broader context of APIs, covering the latest OAuth top 10 risks, authentication and authorization considerations, where it can fit into the API lifecycle, so where we can bake security in from a design perspective, but right the way through all the way into managing the production API. And then we covered a subsection of the common vulnerabilities that myself and Jose were discussing leading up to this. So thank you everyone for your time, and we now would like to spend the next few minutes, and myself and Jose don't have a strict stop, so we're happy to answer any questions. And I would encourage anyone that wants to connect to Jose and I, please do. And again, here is the QR code for Jose's great book on microservice APIs.
Thank you.
Let's start taking a look at the Q&A, Jose.
Sure. Well, thank you to all also for attending.
So I have two questions coming in from Deepak, and the first one is, how would you perform security testing for vulnerabilities on APIs? Right,
so that's actually something we may cover in more detail in a different webinar, but I think there are a lot of great tools out there to do testing and validation of APIs from both a security and kind of like a compliance point of view in terms of complying with the specification. Some open source tools I can recommend are schemas that does API validation against the specification, and FANSA, which is an open source API security testing tool that I'm building myself. And from the SmartBear ecosystem, I can also recommend Packflow and Ready API.
Yeah, great. And the second part of the question from Deepak is how to secure API calls between the microservices. So we did cover that. So if it's kind of, let's say, component to component, there's different techniques. So if the flow is that we expect we're going to have a token, then we can have kind of delegated chaining or on behalf of flows. So you'll have the tokens being passed along and the different microservices. Without that, of course, a client credentials OAuth implementation is a solid mechanism. And again, from each component should not necessarily have zero trust. So it should make sure that it expects every requester to issue a token. It should validate that token and validate the scope that's applicable for the consumer making that request. So we have another question from Peter Wright. There's actually two questions rolled into one. And the first is, how early in the API design implementation process is it best to adopt this approach? And then any tips for driving a security-first mindset across larger teams?
Right, so I think the earlier we can start including this approach into our secure API design and implementation process, the better. But of course, in the earliest stages, you were talking about the life cycle, right, Frank? So there's the first stage in which we do alignment with the business. We want to make sure we have clearly differentiated operations, processes, and flows within the API so that we can map them separately to different operations in the API when it comes to the design. What I would do is, as soon as we have some form of design in place, let's start thinking about the possible vectors of attack we have in there, and we can leverage some of the tooling that I mentioned, including so schemas, FANSA, Spectral is another great tool here. So those tools will give us a lot of feedback about how our configuration is, or how our design is playing with the rest of the system. They can highlight a lot of problems in that.
Yeah, absolutely. A lot of it goes back to kind of standardization and governance. So putting in place kind of the guardrails or the guide rails that can be automated, so it allows teams not to spend too much time reinventing the wheel as to how to solve some of these security risks. So try and make a good decision. So if there's any type of concept of an API guild or a group of folks that are supporting teams build consistent APIs, and then they will create the standardization rules from a security perspective. Again, making sure that they are then validated through the design definition phase, but also that they're rechecked as part of the automation. Proving that the API implementation matches the design definition is also crucially important. So if you do a good job in making sure that your design is solid with a good security mindset, make sure that you prove the implementation is actually matching the design appropriately, and make sure that you've testing there to prove that. A lot of the API tools that are out there, SmartBear tools, open source tools, other vendor tools, will have a concept of at least being aware of the OAuth top 10, have various levels of support for scanning your APIs against that recommended list. And that gives you a very good basis to move forward and have something repeatable so that you don't let things bleed in. We touched on the configuration challenges. So again, having something like a well-known configuration for your target servers and making sure that those configuration profiles are applied and validated so that you're not letting, let's say, development or test configuration settings leak onto your production environment as well.
100%. I think that's really solid advice, Frank.
So I'm trying to think, see if there's any other questions. So there's a question from Rob. What types of API security testing and or monitoring would you recommend an organization to start with on their API journey?
Right, I think I think some of the tools that we mentioned are a great way to get started. What I will do really in many cases is to, when I'm working with a client, is to get started with some design implementation, and then run, for example, a schema thesis as soon as possible against the API. It runs against a running server, because that's going to give us a lot of feedback about the strength of the design. So I think something like that, as soon as you can start incorporating automated tooling, because a lot of these things also go back to the problem that as humans, we're going to make mistakes. So we want to incorporate as much tooling as possible to automate these checks and make sure we can focus on the actual application development process, as opposed to having to spend so much time on designs of security here and there. What do you think, Frank?
Yeah, I think that makes sense. Like, I'm definitely an advocate of design first, because I do really appreciate the affordances that a design artifact like an open API document can give me and the teams that I'm working with, because that will allow us to automate and boilerplate. It's not going to do all of the work for us, but it gives us a common artifact that we've all collaborated on, that we also have feedback from the customer before we start implementation that, yes, if you deliver an API according to this design, it's going to solve the problem as we expected or as we want it to be solved. So then it allows the testing team and the development team to start working in parallel, so that there's just a very natural collaboration, and we're all referring back to this common artifact. And then we have surrounding us any standards that we have and tooling for enforcing good API standards from the start. And that probably is a little bit of a lead on to the follow-up webinar. So myself and Jose hope to do a deeper dive session. So this was kind of a theory session, and we'll be getting our hands dirty with API designs and with code, and trying to take an API through the process of working through the design, showing common pitfalls, how we're addressing those pitfalls, how we're verifying them from a code perspective and a testing perspective. We don't have strict timelines yet, but we're expecting that will be somewhere in early October.
Very looking forward to that.
Great. So let me see if there's any follow-up questions. If anyone has any questions, feel free to put them in now. So there's a question from Roman, and it's directed to you, Jose, and it's your book subtitle is Using Python Flask, Fast API, Open API, and More. How useful is your book to a Java developer?
I think it's still useful. It's like 50% of the book is focusing on technology agnostic aspects of the API, like JSON schema, explaining how OpenAPI works, the schema definition language for GraphQL. There are 2 chapters on GraphQL that don't touch on any implementation details with Python or Flask or any of those. And so those chapters are variable for any kind of a stack. They are applicable just the same. The testing chapter is also implementation independent, because it explains how to use a schema thesis and how to automate this testing process. The microservices design chapter is the same. It explains how to bring domain-driven design to break down the system into independent services. And even the chapters that contain implementation details, they still bring a lot of general concepts that are still applicable regardless of the stack. So explaining general patterns like the unit of work, or some of the patterns, those are ideas you can still bring to other stacks and languages. And the important thing is the concept, really. What I emphasize in the book is that regardless of the framework or the technology you're using, the important thing is to understand the principles and patterns of API development and microservices development. That's what is going to help you implement robust services and APIs regardless of the stack.
Yeah, I think that's like a general rule of thumb, or the way that I also look at API design in general. Your API is the interface, and it's a representation of the behavior of the capability, and the actual implementation itself is open to change. And as a consumer, I shouldn't really care if the implementation is completely changed, as long as the API still performs as advertised in its contract. And then I will have other non-functional requirements, like this is going to be secure.
Exactly.
So I think, from a patterns and principles perspective, I think that makes complete sense. But thanks for your question, Roman. Okay, I don't see any questions coming up. Jose, I appreciate everyone who has stayed on 9 minutes past the hour. Hopefully this is some value, and just to say again, all of the slides with even more information than we had time to cover today will be shared along with the recording, so expect to see that soon. And we will be also raffling off I think 4 ebooks, Jose. So
Yes.
two for your book, and also 2 for I actually have it here, for Designing APIs with Swagger and Open API from Josh Ponoleth and Lucas Rosenstock, as well as 15 free signups to your API course with Python. So thanks everyone. Have a good rest of your day and evening, and we will speak to you soon.
Thank you.